back to this channel. So in today's class we want to define function. Now, have you ever seen word like this? Y is equal to f of x. So you can see that this f of x, it's not the same thing as f multiplied by x. It's not this. It's called y is a function of x. Now that's the meaning. So this function is like mathematical machine. That is, you input data, you put in data, input, that input is in form of x, then it processes that f of x, and it gives out exactly one output. This is output and it's usually y. So that is the meaning of function. You input data, you put in x, then the function processes it, then it gives out exactly one output. Now, mathematically, you can say that you are considering two non-empty sets x and y. Considering two non-empty sets x and y, then a function is a rule that assigns to each element in set x exactly one element in set y. Now, it shows that wherever you are imputing x, you must get exactly one solution, exactly one answer. So if you have, this is x, this is f of x. Let's say this f of x is equal to x squared. So you have 2, 3, 4, 5, 6. So if you input, wherever you see x here, you are going to put 2. So 2 raised to power 2 is equal to 4. You can see that it gives exactly one solution. So 3 squared gives 9, exactly 1. 16, 25, 36. So they give exactly one solution. So another definition that we can use is that after considering two non-empty sets x and y, then a function is a connection. Is a connection between x and y such that all elements in x is associated with some elements in y. 2. The association or the connection is unique. That is the meaning, that it must be exactly one solution. One x goes to one y. Now, let's use this example arrow diagram to explain. Let's say we have children. We have ladies or women. Now, this is the input and here is the output. So, what is the rule? What is the connection? Let's say we want to talk about motherhood. Now, let's say this is one child, another one, another one, another one, another one, another one. And we have how many women? Let's say we have 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6 as well as children. We have 6 children and we have 6 women. So this one is now looking for his or her mother. So she's saw the mother here. Another one also looking for the mother. Oh, here is my mother. Can we say that this same child now still see another mother and say this is still my mother? You know, it's not possible. There's no child that has 2 mothers. So that's it. So that is why we say that all elements in X is associated with some elements in Y. Or from this example, definition 1, that is a rule that assigns to each element in set X exactly 1 element in set Y. So it means that there won't be any child that will have 2 mothers. But this one is still looking for his or her mother. So he saw the mother here, which means that 2 children can come out from the same womb. That is 2, maybe this is the elder, this is the younger one, so they can have the same mother. Another one also looking for his or her mother, so this is still the same mother, so it can happen. Now this one also looking for mother, so the mother here. We now want to leave this one. Is it possible? Is there any child that will not have mother? You can see that it is not possible. So this one also looking up and, oh, this is my mother. Can you see? That's why it say that all elements in set X, all elements. It means that there won't be any elements here. There won't be any variable here that will not be assigned or that will not be connected or that will not be related to at least some of the elements in the output side. So here is the input and here is the output. So let's say here is set X and here is set Y. So all the elements in set X must be connected to maybe all of the elements in Y or some of the elements in Y. So that is the definition of function. So now here is the arrow diagrams. You can see that is diagrammatic representation of function. So we want to check if all these function, we want to show which one is a function and which one is not. Now let's check for number 1. Here is the input 1, input A. Now it assigns to output F. Then this A also still assigns to output K. So if because of this reason alone, it's okay. So we can see that this is not a function. It's not a function. Why? Since one input is assigned to 2 outputs, so it is not a function. Now let's check the other one. 1 is assigned to 1, 2 is assigned to 4, 3 is assigned to 9, 4 to 16, 5, 25. We have other 2 elements here untouched, so it doesn't matter. So since all the elements in the input is assigned to exactly 1 element in the output, that means it's a function. Reason, since each element in input is assigned to exactly one output, so one element in the output variable. Now number 3, the first element in the input is assigned to one element in the output. The second one is not connected to any output. So because of this reason alone, it shows that this is not a function, because there is one element in the input that is not assigned to any element in the output. So that is the meaning of that one. So if you find this video very useful, please don't forget to give it a thumbs up, and if you are new here, please subscribe to my channel. So in the next class, we're going to define what input really means and what output really means. So till I see you in the next class, thank you, bye bye.